Assalamualaikum. My name is Maya Myra from HD129. Today, I'm going to explain about galvan itself, example, including its reaction, observations, and calculations. Okay, so based on the two half reactions given, the E value, so to identify which one is anode, which one is cathode. If anode, the E value will be more negative because it loses electron, while the more positive value is the cathode because the electrons are gained. Okay, so we know that when anode, it means that the oxidation reaction occurs, which is the loss of electrons, while cathode, it means that reduction occurs, which means the gain of electron. Okay, so based on the chemical equations for anode, we know that our anode is manganese solid, loses electrons, forming Mn2+. So this is 2 electron. And for cathode, we know that chromium ion Cr3+ gains electrons to form chromium metal. Okay, so in the overall, we have to balance the electrons, and then we can write the whole equation correctly. Okay, so the observation for the solid electrode for the anode, which is the manganese electrode, oxidation causes manganese to dissolve into the solution, resulting in a decrease in mass of the electrode, while cathode, which is the chromium electrode, reduction causes Cr solid to deposit on the electrode, leading to an increase in mass. On the next page, we know that the anode is manganese solid on the left side, which is the negative terminal, while the chromium solid on the right side, which is the positive terminal, is cathode. Okay, so we also know that electron flow occurs through the external circuit from the anode to the cathode, which is from the left to the right. As I written here, the electron flow is to the right. Okay, salt bridge completes the circuit by maintaining electricity neutrality, allowing ion to flow between two half cells. Okay, for the cell notation, we know that when it's anode, it must be on the left, while for cathode, it must be on the right. And the ions must be in the middle, and you cannot put solids each other, which is on the middle. So each solid must be on the end of each cell notation. To calculate the standard cell potential, we use this formula I have written here, which is E red cathode minus E red anode. Okay, so we write the ions first, which is Cr3 plus aqueous. Then we write chromium solid minus E and Mn2 plus aqueous, and then Mn solid. Okay, so we have to know the value, so we just substitute the value on the correct place, and then you will get the value, which is positive 0.44 volt. Okay, so the oxidizing agent, which is Cr3 plus aqueous, it gains electrons during the reduction process. So we know that Cr ion 3 plus is the oxidizing agent, while for the Mn manganese solid, we know that it loses electrons during oxidation. So that's how we identify manganese solid is the reducing agent. Here are two functions of salt bridge that I have searched, which is to maintain electrical neutrality and completes the circuit, to make sure the electrons can flow through the two half cell. In summary, this galvanic shows how chemical energy is converted into electrical energy through redox reaction. The manganese electrode is oxidized and the chromium electrode is reduced with a standard cell potential of positive 0.44 volt. That's all from me.